All right, so this is our last topic for our unit heat and temperature. We're looking at topic 8, conserving our fossil fuels. All right, so we've talked about fossil fuels quite a bit in our last topic. So there's many disadvantages to burning fossil fuels, but we still use them. We still use the coal, oil, and natural gas, and we looked at the pros and cons last class. So things like cost, and setting up facilities and so on. So fossil fuels were firmly established as an energy source and as a major part of Canada's and the world's economy. And then scientists started to realize and observe that there were all these problems that were associated with them. People just assumed that fossil fuels would always just be available. People believed that the unwanted gases would simply just be absorbed by the atmosphere and they won't cause any problems. So concerning our fossil fuel resources, so things we can do to conserve our fossil fuel resources, we can do things like turning off the lights or appliances when we're not using them. That reduces electricity, which is being powered in power plants by burning fossil fuels. We can reduce emissions from vehicles, right, by taking public transportation, carpooling, biking, walking, insulating homes and water lines. We can also reduce the amount of energy we use, have a programmable thermostat in the house so that temperatures can be turned down when you leave the house or maybe during the nighttime. So here, programmable thermostats, they are able to adjust the temperature so that the home can be cooler when you're not in the home or when you're sleeping. So it's one method of saving energy and money at home. This here is taking a look at a recirculating system that pumps hot water. So it's like if you've ever noticed, if you turn on a tap and if the water is instantly hot, then it's probably using this type of method. It's a recirculating hot water system. And this saves energy. It also provides instant hot water at all times. So next is refrigerants. So firstly, thermal energy movers. That's a device that can transfer thermal energy from one location to another location at a different temperature. So things like refrigerators and air conditioners. So refrigerants, they depend on the process of evaporation and condensation. So these refrigerants, these are liquids that evaporate easily at low temperatures. So they're basically used in refrigerators and air conditioners to remove, so in a refrigerator, they would remove thermal energy from the food, and then that liquid, that refrigerant, gets pumped through the coils inside the refrigerator. And then as that liquid evaporates, it absorbs thermal energy from the items in the fridge so that they cool down. Warmed gas pumps to a compressor at the back or at the bottom of the fridge. That gas is compressed, the temperature will rise above room temperature, and then it will lose the thermal energy to the air in the room, and then it will condense back into a liquid again. All right, so that's how refrigerants work in a refrigerator. So here's just a diagram showing how a refrigerator is a thermal energy mover using that liquid refrigerant and the processes of evaporation and condensation. And then on this side here, this is an EnerGuide label. So you will find these on most household electrical appliances, kind of like dishwashers and washer dryers and so on. And this tells how much electricity in kilowatt per year an appliance uses in 1 year under normal use. So here it's showing 582 kilowatt hours. And this red arrow is showing more to the left-hand side. If you move more to the right-hand side, it's less energy efficient. So more to the left-hand side, it is more energy efficient. Dangers of thermal energy. So things we've already talked about, like burns and forest fires, so on, would be harmful effects of thermal energy. Storing fossil fuels can also be a fire hazard, and it also pollutes the environment. Any large storage tanks that are buried underground, they can also lead to leakage, which can leak harmful chemicals into the soil. Chemicals that are used during manufacturing petroleum products can also end up in the soil and water, and then trying to return the soil to its original state, it's very expensive. That's called a reclamation program, and you cannot use that soil until it has been restored. So it's very important that using and storing fossil fuels are done in proper care. Just continuing here with dangers of thermal energy. So here we're just looking at forest fires. In Canada, many thousands of square kilometers of forest fire burn each year, and it could be set off by lightning. It can also be set off by campfires or careless use of fire in the wilderness, cigarettes, and so on. And here, just looking at a conductor, copper is a good heat conductor. And therefore it will cook the food evenly, it'll prevent burning and scorching. And then this oven mitt would be a poor conductor, therefore thermal energy can't be transferred from the hot pan to the hand to cause any burns. Some byproducts of thermal energy use. So like we talked about when we were looking at fossil fuels, carbon dioxide is a gas that's released during the burning of fossil fuels. It's a greenhouse gas. So it's trapping energy, the heat energy in the atmosphere, and it's leading to global warming. And then when we burn coal and sulfur-containing natural gas or oil, they're also releasing other gases while they burn, specifically sulfur dioxide. So it's a gas, again, it's a noxious gas, extremely irritating to the eyes, nose, and throat. Now, sometimes if a fire is burning without enough oxygen, another gas is produced. This is called carbon monoxide. It's a colorless and odorless gas, and it is lethal. All right, so symptoms include like dizziness, confusion, and death. So people can die in their houses or their cars from inhaling this gas. So it is recommended by the Government of Canada that every house contains a carbon monoxide detector, as well as the smoke detectors. And nowadays you can find one device that will do both. All right, so there is no perfect energy source. So we looked at all those energy sources. We looked at pros and cons for each type of thermal energy. So for example, the renewable energy sources, some pros for those. It's limitless, it won't run out. It's free to use, it's environmental friendly, but the cons include it's difficult to set up, right? The initial setup is costly, so it's expensive to do that initial setup. It's not always efficient because we need large amounts and it's not always available, like sunlight or wind. And then non-renewable energy sources like the coal, oil, natural gas. The pros, it's cheap to use, it's easy to use, it's also efficient. You only need a small amount of it to produce a large amount of power. But the cons, it's going to run out someday. All the environmental damages that it's causing, global warming and so on. It's releasing toxic gases, leading to global warming, climate change, and as well, prices. Prices are going to continue to rise as supplies are running out. All right, so we'll stop here, watch 2 of these videos.